Welcome back, guys. We have been talking about desert adaptations. We're currently covering animals, and then we're going to be covering plants after that. So last week we were looking at reptiles and amphibians of the desert. This week we are looking at mammals and birds of the desert. Some of their adaptations are similar to what we see in reptiles and amphibians, sorry. Some of them are different, so we will look at same challenges. Obviously, we've got heat and we've got lack of water, but we're going to look at how these mammals and birds deal with that. So we have three different ways to endure high temperatures. The first one is to reduce heat input. Okay, so sitting in the shade. We all know about that. Living here in Arizona, the best place to be is in the shade all the time because you get less heat coming in. So basically you have to stay out of the sun, and animals find a lot of ways to do that. So they can shade themselves. Plants have spines. Animals have fur, so using fur, which is kind of counterintuitive to me to think that fur is going to make them cooler, but it actually does. Sometimes it insulates them from the sun. By posturing and orientation, so they can leaves turn themselves sideways so that they have less of their surface area exposed to the sun. Animals can change their posture, things like that, so that less of their body is also exposed to the sun, minimize surface area exposed to the sun. By insulation, as I said, by shiny surfaces. So you'll see most of our plants have shiny surfaces on them to reflect heat, but actually some of the animals, their fur is actually glossy, and so that helps them reflect sun as well. So all of that is for reducing heat input. Second way to get around heat is to dissipate heat. So they have to come up with ways to dissipate heat. If they get it inside their body, they have to figure out how to get it back out of their body. So they use evaporation in those animals that have enough water content in their bodies to be able to use evaporation. So in order for evaporation to work, it's often sweating, sometimes panting, but either way you're losing water out of the body in order to cool yourself through evaporation. So as I said, water is a limiting factor here too, so only animals that have enough water in their system can use evaporation as a mechanism to dissipate that heat. A lot of animals in the desert, I'm going to show you quite a few of them, but a lot of animals in the desert have long appendages, okay, much longer appendages than you would see in animals that are not adapted to the desert. And these are used to basically exchange heat with the atmosphere. Often in these long appendages, you'll have lots and lots of blood vessels, so that heat can be shunted to these long appendages, and then heat can be pulled out of that blood through these long appendages, such as legs, ears, etc. We'll look at some of those in some of the animals. And then also small bodies. So where the whole body or the whole leaf, etc., can radiate heat out. So you'll see that a lot of desert animals are very small. Desert animals that are very small, we'll talk about soon, is not going to be able to use evaporation as an option. And then we have a few desert animals that actually tolerate what we call hyperthermia. You guys have probably heard of hypothermia, where you get too cold, but hyperthermia is actually where you get too hot. So some plants and animals can actually survive body temperatures that are raised and would be dangerous to humans. So we have a limit to how high our body temperature can go, and some of these animals and plants are able to raise the internal temperature of their bodies to get around that. And therefore they can exchange heat with the atmosphere for a lot longer than we would be able to, because their temperature on the inside is equal or above the temperature on the outside. So for example, this antelope squirrel here in the picture you can see can tolerate body temperatures of over 104 degrees Fahrenheit. Anyone who has ever had a fever higher than 104 or even 104 knows how absolutely miserable you feel, and humans cannot tolerate a fever that high for very long. So these animals do that on a daily basis. So decreasing metabolism. We have to go back to maybe your Bio 181 class that you took, talking about cellular respiration. Metabolism, remember, is the sum total of all the chemical reactions going on inside your body, creating, growing new things, breaking down things, and all of those reactions create heat, because all of our chemical reactions are not fully efficient. So heat is always given off. That's what creates our body temperature. But the higher your metabolism, the higher your internal body temperature is going to be. So several of these arid adapted mammals have figured out ways to reduce their body metabolism during the summer. For example, not all of the animals that I'm going to talk about in this lecture are found in the Sonoran Desert, but remember Dr. Alford talked about deserts all over the world, so I'm going to talk about some animals that are found in some other deserts as well. So a lot of the gazelles and Auroch species that are found over maybe in the Sahara Desert, things like that, over in Africa, Asia area, they reduce their basal metabolic rate by 50%. In the summer. So they bring their metabolic rate down, and usually that is standing around, not moving a lot, not eating a lot, but not really just standing around. Sand gazelles, it's only 20% of their normal basal metabolic rate in sand gazelles. Reducing metabolism reduces water loss as well as less heat being created on the inside. So water loss from respiration. So when you think about breathing, the air coming out of your mouth is much wetter than it was when it went in. Your body is used to wet that down so that you don't lose a ton of water when you're breathing, but a lot of that water comes back out. So the air that we are respiring has a lot of water in it. So reducing that metabolism not only reduces water loss, it also reduces our internal body heat creation. These animals that are able to reduce this metabolism so that they lose less water are then able to use evaporation as a mechanism to help them get away with cooling off through evaporation. A lot of animals in the desert are nocturnal, okay? I'm sending you guys out on your hike and looking for animals. Many of you may not see animals. We don't see a ton of animals in the desert, and that is because generally we're not there at night. Most of these animals they're active in the mornings and they're active in the evenings. Some of them are active only at night in the summertime because obviously you are gaining less heat from the sun. We all know that it gets cooler in the desert at night in the summertime, so they remain inactive during the day. And then in the evening, they come out, and that reduces their internal and external body heat loads. Deserts are cool in the evening, well, cooler at least, and so animals that have built up metabolic heat during the day can then dump off that extra heat at nighttime when they're not getting the sun beating down on them and creating more heat from the external. So the desert is alive with animals at night. If only we could go into the desert at night and see all the animal life. That's where we're really going to see it. So hopefully we can see some of those animals in the desert, but often we don't see that many because they're active at night. Let's talk about evaporation for a minute. As I said, evaporation can be a good mechanism for cooling because evaporation, basically when you go to the gym, and you're exercising and you're getting really hot and your skin turns bright red, that is because all of your blood is being brought out to the surface of your skin so that you start sweating. That sweat then evaporates off your skin and it takes that heat with it. And it allows you to cool off. Same thing happens in animals, okay? If they are able to sweat, there aren't that many animals that are able to sweat, but they can use that sweating. They also use panting, okay? Dogs pant, they don't have sweat glands. So dogs pant and they lose water and heat through their panting mechanism, through their mouth membranes. And then some other animals lick their extremities. So it's not always just they're cleaning themselves, but sometimes they're licking their extremities and getting that saliva on their legs or their ears, whatever it is they're licking, and then that water is then evaporating off of there and taking heat with it. But as I said, in these small animals, one of the adaptations to the desert is to be a small animal, and they would lose so much water from their surface area that it isn't an option for them. They would die if they tried to use evaporation as a mechanism to reduce their heat load. So if we look at this graph here, you can see in the red, that is the line that shows right here, you can see these are animals that are out in full sun during the summer, in the summertime. And this is how much water they would need to lose in order to be able to dissipate heat through evaporation. And you can see that as the animals get smaller, it gets too difficult for them to be able to use evaporation. They would lose way too much water and they would die. So basically anything that is mouse or rat sized would have extremely high rates of evaporation no matter when they're out there, particularly under the desert sun, and so evaporation is just not an option. In this blue line here you can see this one is in the shade, okay? So animals are resting, they're not exerting themselves at high temperatures, and you're still losing a decent amount of water. We all know that when it gets to be 115 degrees here, we all sweat no matter whether we're sitting in the shade or not. So evaporation works for us, not so much for these little small animals. And there are a lot of small animals out in the desert. So a small animal, which is 10 to 100 grams, would have to evaporate water at a rate of 15 to 30% of their body weight per hour. And anything above 10 to 20% in a day would be fatal. So there's no way that they can use evaporation as a mechanism to get rid of their heat because it would require them to lose too much water. So they obviously have to come up with different ways to adjust and get rid of that heat. So let's continue to talk about evaporation. Then we will get to these smaller animals and figure out how they do it. So sweating. What animals are able to sweat? Usually it's the larger animals, because the larger they are, then the less water they're going to lose as they sweat, and it's safer for them to be able to use sweating as a mechanism. A lot of smaller animals don't even have sweat glands, so they don't even have that option. So primates, many large hoofed mammals, so horses, cattle, large antelopes, camels, things like that. So the antelopes, aurochs, camels, things like that can use sweating for evaporation. A lot of the smaller animals use panting. Even birds use panting. I don't know if you've ever seen a bird pant, but it's this thing called a Goulart Flutter where they basically move the skin of their neck back and forth really fast over their mouth membranes, and that allows them to excess heat out of their body. Most carnivores also use panting. So as I said, dogs, they pant, no sweat glands. And then some animals like kangaroos and some rodents actually use licking their extremities and covering those with saliva and then having the saliva evaporate off their bodies. Kind of gross, but if you are going to die otherwise, then it makes sense. So, second option is dissipating heat. So rather than evaporation not being an option for a lot of animals, so they dissipate heat with extremities instead. So a lot of appendages with blood flow. And there's a lot of capillaries in these appendages. Say in a jackrabbit with these big long ears, you have a lot of blood capillaries in there, and they can send the high heat of their blood out to those areas, and that exchanges heat with the environment. It will continue exchanging heat with the environment until the temperature inside that animal equals or exceeds the temperature outside in the environment. There are also shaded areas of the body where they have a lot of blood flow. So capillaries in a shaded area of their body can bring that heat from the blood down and allow that to escape, because the air outside the shaded area of that body is going to be cooler. So they can continue to exchange heat with that shaded area of air. And then also some animals use evaporation and blood flow. So looking at an antelope jackrabbit, for instance. A desert jackrabbit, okay? I'm from up north. We have jackrabbits up north as well. And the desert jackrabbits that we have down here look quite a bit different than the jackrabbits we have up north. So in desert jackrabbits, they have these giant ears. And as this light is shining through here, you can see all of the blood vessels inside those ears. Those are all being used to dissipate heat. They look a little strange, but it allows them to be able to dissipate enough heat in order to live in these very, very hot environments. So in this animal, their ears make up 1/3 of the surface area. So very, very large ears, which allows them to dissipate a lot of heat through those capillaries in those ears. So this is a graph showing that. You can see here's a thermal image showing you that those ears get really hot. So when they're exercising, the heat inside those ears goes way up. So the temperature inside those ears goes way up. And then as they are able to dissipate heat, after they are resting now from their exercising, you can see that they're able to dissipate that heat and bring it back down. So getting rid of that internal temperature through those capillaries in their ears. Here's a comparison between the white-tailed jackrabbit in the northern hemisphere, okay, that we see out in the Midwest, things like that, versus the black-tailed jackrabbit, which is found in the desert. So you can see the ears are a lot smaller, okay, they don't have as much surface area, so they're narrower across. And we have a smaller body size here, so they're going to absorb less heat through their body. Longer legs also for heat dissipation, so they have longer appendages that they can get rid of heat as well through their legs and through their ears. Generally, you'll also have lighter colors in animals that are adjusted to the desert, not only to blend in with the environment in the desert, but also to decrease the amount of sun that's going to be absorbed through that fur. Here we have a different species of desert rabbit. So this is the desert cottontail, okay, different than the jackrabbit, versus the eastern cottontail. This is the desert cottontail here. This is an eastern cottontail, which will be found up north, that is not aridly adapted. You have a lighter coloration in the desert cottontail. You have longer ears. Once again, you can see all the capillaries in those ears, so you have a much larger ear surface area. And you have that lighter color, which helps them blend in, as well as helping them absorb much less sun than they would otherwise. Here we have a comparison between kit foxes, which are desert adapted foxes, versus the red fox, which you find up north. So much larger ears in the kit fox. They're kind of a little bit of an interesting looking fox because they have such a small head and these great big ears sticking out with that large surface area on the ears. They have longer, much longer, skinnier legs. So you see those there, much longer than these legs and skinnier than these legs. So once again, being able to have a lot of those capillaries near the surface to dissipate that heat. And they also have densely furred feet. So there's a lot of fur on the foot of a kit fox here that protects them from heat coming up from the ground. And it also gives them traction in the desert. You know, it's rocky, it's sandy, things like that. So it allows them to move around a lot better in the desert. Foxes generally moving around in the forest up north, red foxes. Talking now about desert bighorn. Okay, there are bighorn up north that are not aridly adjusted. And then there are ones that are found here in the desert, are desert bighorn that are found here in Arizona. These guys dump heat through their bellies. Okay, so they have lighter colored bellies. You can see we've got dark up here. We have lighter colored bellies. We have much, much less fur under here in the belly, and it's shaded. So the air underneath this belly is going to be cooler. And that allows them to exchange heat with this air under the belly for a lot longer than they would be able to if they were trying to exchange the air up here is quite a bit hotter. So the ventral surface, which means the belly surface of many large mammals, very short hair, sometimes almost nude underneath there with very little hair at all. So in camels, guanacos, which are similar to llamas, Gemsbok, all of those have this thing called a reedy mirabile, okay, which is a capillary bed that is found in these lighter areas under the ventral surface and allow all of that heat to be dissipated by bringing that blood down to this shaded area underneath their belly. This also shows, this is looking at Iguana Co, which is adapted to deserts down in South America, looking at the places on their body that they have more fur versus less fur. So they have quite a bit less fur. So the fur underneath here in that white section, that's about 1 millimeter long. whereas this darker fur up here is going to be 30 millimeters long. That seems like, oh my gosh, I have all this fur, it's very hot. But actually that thick fur up here is used to insulate against the sun being able to beat on them and create that internal heat on the top. So they basically have different lengths of hair in different areas of their body. So on the legs here, 4 millimeters. So they've got shorter hair there, so they're able to dissipate heat in their legs as well. Then they can also adjust these heat windows by changing their body posture. So if they want to spread out more to expose more of that belly to the shade, they can change the shade area underneath their body, put their legs up underneath their body so that their legs are in the shade as well. And that allows them to dissipate a lot of heat through these different areas in their body, as well as insulate other areas where it's important that the sun is not beating down on those areas. So I talked about fur and reducing radiation with fur. So they can have thick fur, which is insulating for them. And they have done studies where they've sheared camels, and the sheared camels lost 50% more water through evaporation than those with a heavy coat. So basically those animals that are able to use evaporation, like a camel, some of those larger gazelles, things like that, they're going to sweat. If you cut that fur off, they're actually going to sweat through that skin instead of with the fur on there. It protects them from that sun and they're not going to sweat. They're not going to lose as much water. So it's really important for them to have that thick fur in order for them to be able to insulate themselves from the sun and then not to have to sweat through all that surface area. Most desert animals are also very light colored, so you can see in these antelopes here, they are very light colored, and their fur is often glossy, so it's reflective, and it actually reflects about up to 20% of the light that's coming down and hitting them. So we've all been outside, walking to class, whatever, and you're sweaty by the time you get there because the sun is just beating down on you, beating down on you. Well, in these animals, they are lighter colored. We know that lighter colors soak up less sun, and then they're also glossy, which reflects a lot of that sun back, allowing them to not get as hot as they would otherwise standing out there in the sun. All right, so let's talk about those little animals, the ones that are not able to use evaporation, and figure out what the heck they have to do. Most of the time, they do what we call evading heat, okay? So they might be sitting in the shade. They might dig down into the sand a little bit in the shade and allow them to get to the cooler sand underneath. They might live in a burrow most of the summer, so they go underground. Underground, it's much cooler. And they might even go into what we call estivation in a burrow. Estivation is similar to hibernation. It's basically hibernating in the summertime to avoid the heat. So we're going to look at all these options for these little tiny guys that have too much surface area to volume ratio in order for them to be able to use evaporation as an option. So, reducing heat intake. If you look here, here is, say, a rodent burrow. They dig a burrow down underneath the ground, say about 1 meter underneath the ground, and a kangaroo rat, for instance, at about 1 meter underneath the soil, the surface temperature remains between 15 degrees Celsius in the wintertime and 32 degrees Celsius in the summertime. Whereas out here on the soil surface, in the summertime, that heat can get up to 50 degrees Celsius in the summer and 7 degrees Celsius in the winter. So it's much cooler in the summertime and actually even warmer in the wintertime. So it keeps them warm in the wintertime and it keeps them cool in the summertime. So, as I said, almost all small animals have to evade because they don't have the option of dissipating heat. They don't have these long appendages to help them dissipate heat, and they are not able to use evaporation because they would lose too much water in the process. So 93% of Sonoran desert rodents are nocturnal. It's why you don't see rodents in the desert. The desert is full of animals, but most of the time you don't see them because most of the desert rodents are nocturnal. That's fine with me. I'm not a big fan of rodents anyway, so I'm not bothered by the fact that I'm not seeing them. But most of them are nocturnal and most of them do estivate, which is like a hibernation in their burrow in the summertime to avoid the heat, whereas hibernation up north in the wintertime, that's to avoid the cold and the lack of food in the cold. So let's talk about some animals that actually cope with the heat. Okay, so there are 4 species of rodents in Arizona deserts that are what we call diurnal, meaning that they are active during the day. They are all ground squirrels, and they all deal with the heat behaviorally by creating their own shade, running into the shade, things like that. So some of these ground squirrels have big fluffy tails that they bring up over top of their head and basically create their own shade tree with their own tail and shade themselves. Many of them show daytime activity, but they show a seasonal shift in behavior. So here we're looking at January. This is from 6 a.m. down to almost 11 p.m. So they're very active starting at 7 a.m., stay active, and then they slowly die off in the evening. Whereas in August, when it's the hottest, potentially July, June, whatever, in the desert, you see activity starting at 6, goes to about noon, and then it picks up again about 4 and goes later in the evening. So they take a break during the hours when it's hottest in the desert. They go into the shade. So they're still active during the day, but they just kind of modify the hours in which they're active. So you can see here the round-tailed ground squirrel, the white-tailed antelope squirrel. Here's another one up here. And then you can see the daily activity profile here. So this is, you can see how the body temperature goes up. This is body temperature on this side. This is time. So this is time of day here, and showing you that they're much more active. And then their body temperature goes down because they're less active during those hottest parts of the day. And then they are more active again in the evening. So that's more kind of a crepuscular sort of activity pattern, where they'll be active more in the mornings and then not as active in the afternoon, and then active again towards evening, where they can avoid those hottest parts of the day. And they go back and forth between activity and resting. So they'll go back, they'll come out and they'll be active until their body temperature gets hotter than they can stand, and then they go lay in the shade for a while and they cool off, and then they come back out, and then they go cool off, and then they come back out. A lot of times in the afternoons when it's really, really hot, they'll actually go underground and cool themselves down very much, and then come back out in the evening when it's less hot. So talking about torpor, torpor is basically where they can modify their body temperature to match external temperatures. In this case, they're lowering the body temperature below their active temperature, so pretty much they're just sitting still and not moving. A torpor, going into a torpor state, allows them to decrease their metabolism. It allows them to decrease the difference between their body and the outside temperatures. It decreases the rate of heat loss, decreases the energy needed to replace heat loss. By basically, a lot of times this happens when it gets cold. So particularly in hummingbirds that live down here, when it gets cold in the wintertime, they'll go into torpor and they'll lower their body temperature so that it's more equal to external temperature, and then it doesn't take as much energy for them to heat themselves back up. It also slows their metabolism, which allows all tissues to use less energy than they would. And it saves water. I talked about how metabolism, you lose water. We've all seen the cellular respiration formulas, and you lose water through that. So going into this torpor state, you can see a kangaroo rat and a Costus hummingbird here doing this, decreases cutaneous water loss because you're at a lower body temperature. So lower evaporation rate. You're going to decrease excretory water, so you're doing less metabolism. You're metabolizing less water, less food. So you're going to have to eliminate less often, and you're not going to lose as much water through feces and urine. And then you're also going to breathe less. So you're going to lose less of that respiratory water that I was talking about. So here you can see daily torpor. And here's our predicted torpor energy saving, so how much energy you're saving by going into torpor. So in a female and in a male, our female is our triangles here, and our males are our plus signs. So down here, over time, you are saving 85% of your energy that you would be normally using to increase heat, to exchange heat, to eliminate, things like that. So you're saving a ton of energy by going into this torpor state. And then we have animals that endure heat. Okay, we talked about the ground squirrels a little bit. Now we're going to talk about some of the larger animals that endure the heat. So these are bighorn sheep, and they are actually able to store heat inside themselves. They're able to bring that internal temperature up and make it closer to external temperatures, and then in the evenings they can dissipate that heat that they've been storing throughout the day. They can change their insulation, and they are also able to control temperature with evaporation. So different ways that you can do that. So in heat storage, as I said, they tolerate hyperthermia, which allows them to basically store heat inside their body. It allows them to increase their internal body temperature so that it is higher than external air temperature, and that allows them to continue to dump off heat longer than we would be able to. Heat storage eliminates the need for evaporation during the day, so they're not losing water through evaporation. Dehydrated camels don't sweat, but they allow their body temperature to go up to 111 degrees Fahrenheit. Humans would be dead at 111 degrees Fahrenheit. So they basically store that heat on the inside, allowing them to exchange heat with the environment longer, and then they can dissipate that extra heat later. It also reduces the amount of heat absorbed, because if you're closer to the ambient temperature on the outside, then less heat is going to come in on the inside. So let's look here. This is an oryx. This would be like Sahara Desert over in Africa. So we're looking at the time of day. So exhibiting a high amplitude cycles of body temperature in the summer. So their body temperature, say at midnight, is about 39 degrees Celsius, and then it drops down in the morning and drops down to about 36.25 degrees Celsius, and then over throughout the day they go up, and they get up to almost 40.5 degrees Celsius during the hottest part of the day, and then they start slowly dropping off during the nighttime when they can dissipate that heat when the sun isn't there. So you can see that one is showing that here too. So this is in the winter. You don't see those great big peaks. They pretty much stay around 38. They go between 38 and 39 degrees internal temperature, whereas in the summer they can dissipate all that heat at night, and then they can build it all back up during the hottest part of the day. So talking now about the Gemsbok. This is a species of antelope, lives in Africa, and it is what they say is the most super adapted animal to heat. So recognized as the most adapted large mammal to arid and hot conditions. I don't know if I can show this or not. I don't think it's going to show. Okay, so I'm going to talk to you about the Gemsbok. We have adaptations in the Gemsbok to both heat and aridity. Aridity, remember, is heat, but it's water, lack of water. So we've got heat and lack of water. So Gemsbok don't have to drink. They are drinking water independent. They will drink if they come upon free water and they're able to drink it. And they can also drink water that is almost as concentrated salty as the sea. So they can almost drink ocean water, which obviously we are not able to drink, but they can drink water that is that concentrated. They have the lowest water requirement of any large African ungulate hoofstock animal. Oryx that have not drank free water in droughts over 38 months. So they've had transpondered animals that they've been tracking 38 months. 3 years they haven't drank free water in that entire time. And many live in areas that don't have any free water, and they get all of their water from food, and they super conserve their water. They have the lowest fecal water and highest osmolarity of urine of any large mammal, so they're able to super concentrate their urine, and their feces is basically dry, so they're not losing any water through that. They are feeding nocturnally or crepuscularly, so in the morning, in the evening, or at night. And the reason for that is what they're eating at night is wetter than it would be during the day. So during the day, a lot of that water is sucked out of those plants. At night, those plants are wetter, dew, all that kind of stuff. So they're foraging at night and therefore eating wetter plants than they would be if they were eating during the day. These guys also are able to dig up tubers under the ground, so greater than 1 meter deep under the ground. And they eat these tubers because they have a high water content. They're about 70% water. So they eat these tubers, and that gives them a lot of water that they don't have to drink on a regular basis. And Bushmen out in the desert in Africa actually used to follow the Gemsbok around in order to find tubers of their own that they could then eat as well. Their metabolic rate, I already talked about that, is reduced by 50% in the summer during the day. They have the largest range of internal temperature changes, so they're able to heat store and bring their internal temperature up to really high and then bring it down to really low again. They're able to not sweat when there's no water available. They have been recorded with internal temperatures of 119 degrees Fahrenheit. That is crazy. We would be dead. And they do all of this through panting and dumping heat at night. So they're very active at night, and they're able to, when it cools down in the desert at nighttime, they're able to dump that heat. Their coat is reflective, reflecting 20% of that light that's coming down onto them, allowing them to bring less heat into their bodies. And basically during these droughts, they don't breed. So breeding can be stressful. They want to reduce their metabolic rates, and so they just forego breeding in order to stay alive during these droughts. And then when water comes, then potentially that year they'll breed and have more offspring. So aurochs are highly endangered, and that is potentially why, because they have such a low reproductive rate, because during these drought years out in the wild, they don't even breed. They don't even produce any offspring. So they are very endangered, and that potentially is why. So let's talk about a couple of other mammal species here. Harris antelope squirrel. So one of those antelope squirrels that is able to tolerate hyperthermia. Usually when you're out in the desert in the hottest part of the day, this may be the only animal you see out there, is a Harris antelope squirrel running around. They scurry around collecting seeds and then allow their body temperature to increase. Before they die, before they increase it so much that they die, they'll run over into the shade and they will cool off enough that then they can go back out into the sun and heat up again. These guys do not hibernate. They are active during the day, and they basically allow their heat to come up, and then they go sit in the shade and allow it to come back down, and then they go right back out again. They actually, underneath in these shade areas, they'll lay down in a spread eagle fashion with their entire belly exposed to the cooler earth underneath the shade, and that helps them to dissipate heat quicker into the ground and cool off quicker so that they can get back out and collect those seeds. In desert bighorn sheep, I talked to you about them a little bit already. They also tolerate hyperthermia. They can tolerate up to 107 degrees, which if humans go to 107 degrees, pretty much fatal. They are crepuscular, so they're active in the morning and in the evenings. And these guys can use their horns to break open cactuses. And they then eat the inside of the cactus. We know that cactuses store a lot of water on the inside. So they break open cactuses with their horns, and then they're able to eat the inside of the cactus and get all the water out of that cactus. So let's look now at lack of water. We can store water. So some organisms, some plants, some animals even store water. Animals who store water store it in fatty deposits in areas of their tail. For instance, the Gila monster, the fat part of its tail is actually fat deposits that store a lot of water in there for the Gila monster. Water is often stored in root stems and leaves of plants. A lot of our, saguaros, in our yards at home sometimes store so much water in them that they actually collapse from sucking up so much water. Other animals are able to minimize water loss. They concentrate their urine, they concentrate their feces, so they eliminate excretory water loss, and they breathe differently. They breathe less, so they're eliminating their respiratory water loss as well. And then there are plants, some animals that can tolerate dehydration. So they basically just allow that water to come out of them. If you've ever seen a prickly pear cactus that's all wrinkled up, that's because it's tolerating dehydration, and it can look almost dead, and then it rains and it suddenly puffs back up again and looks just normal. So there are some animals and some plants that are able to tolerate that dehydration, just allow that water to come out. Desert toads, for instance, and then when they get water again, then they fill up themselves again. So let's talk about the kangaroo rat. This kangaroo rat is a pretty amazingly adjusted animal to the desert. Water conserver extraordinaire. So these guys, their physiology has been studied for a long time and how they adjust to conserving water. So obviously, we know we have to eliminate urine in order to eliminate urea wastes from our body. Every animal that breaks down proteins produces urea inside their body and has to eliminate those wastes from their body, or they'll build up and kill them. So obviously, kangaroo rats have to have some urine. Their kidneys can produce the most concentrated urine known in the world. So 15 times more concentrated than humans, so almost dry. Very, very super highly concentrated urine. They have no sweat glands, so they don't lose any water through sweat, and their nasal passages are actually built to reabsorb water from its own breath. So I said most of the time when we breathe out, our air is filled with water. It's pretty wet when it comes out of your mouth. In the wintertime, when it comes out of your mouth, all that water that's in the breath coming out of you condenses because it's so cold in the wintertime, and that's why you can see your breath. So in the kangaroo rats, their nasal passages are used to reabsorb all of that water, so the air coming out of their nose is actually very dry. They reabsorb most of the water that's coming out in the air that they are respiring. So that's pretty cool. They almost never drink free water. They get almost all, if not all, of the water that they drink from their diet. Their underground burrow is humid, so if you dig down under the ground, you can get to more humid sand, more wet sand. Sometimes you can get down to a little bit of groundwater, so it's going to be more humid in there. So you can see this little guy filling up his cheek pouches with seeds. He's going to take all of those seeds and he's going to dump them into his burrow. And he's going to store them in his burrow for a couple of hours. They're dry from being on the surface of the sand. He's going to dump those into his burrow. And in that wet air, those dry seeds are going to soak up that water from the air. And then when he comes in to eat them later, they're going to be a whole lot wetter than they were. And he can actually reclaim a lot of that water from the air inside his burrow by eating these seeds that soaked up the air from the water from the air. So that is pretty darn cool. Let's talk a little bit more about desert bighorn sheep. These guys are crazily adapted to the desert as well. These guys also don't drink much. They can go for weeks or months without drinking. They get most of their water from the food that they eat. They also drink from rainwater that collects in temporary rock pools, but they obviously break down those cactuses and eat that moist food. They can actually lose up to 30% of their body weight and still survive. So these guys tolerate dehydration. They eat food that they can get water from, and they actually tolerate almost starvation. And then after they drink water, they very quickly recover from this dehydrated state. So they allow themselves to go into this dehydrated state when they need to, and then they have the ability to physiologically adjust to being really quickly rehydrated through water when they get it. Let's talk about birds for a minute. So we've been talking about mammals. Now we need to look at birds, because birds obviously have behavioral adaptations to the heat as well. The normal body temperature of a bird is higher than that in mammals. So they are going to be able to exchange heat with the environment longer because of that higher body temperature than a mammal would. So Gambels quail, we see those running around in the desert a lot here in Arizona, running around very quick with the little Q on top of their head. They have a body temperature of 107 degrees Fahrenheit. So obviously they can continue to conduct heat out into the environment until it gets to 107 degrees. So they have a much wider range of ability to conduct heat out into the environment, to lose heat from their body than we do, because we are at 98.6. So much greater ability for that. Most birds have bare scaly legs, so they're able to dump heat out through those bare scaly legs. And then their leg temperature may increase 15 degrees above where it would normally be after they have all these capillaries in their legs, and they can dilate, so open up those capillaries in their legs, and that shunts a whole bunch of blood down to those legs, dry, scaly, non-feathered legs, and the temperature in those legs can increase, and then all of that heat is going to be dissipated out into the environment to get it out of their bodies. So turkey vultures, kind of interesting adaptation here, they actually have black feathers. And you think black absorbs lots of heat, black absorbs lots of sun, I wouldn't think black would be a particular adaptation. But black feathers allow them to heat up in the morning and then cool off during the day. So they also pee on their legs. So they urinate on their unfeathered blood vessel filled legs, which allows for evaporation to then cool them off and take more heat out of those legs than they would be able to otherwise. But if you ever see a turkey vulture, often they have white legs, and that is because of the urea in that urine staining their legs white, because they pee on their legs in order to evaporate heat out of their legs, which is kind of an interesting adaptation. This thing I was talking about called Goulart Flutter, this is the way that birds pant. Basically, they flap a loose skin underneath their throat that moves air over their mouth cavity and allows them to evaporate heat through their mouth. A lot of owls use this Goulart Flutter to cool off in the desert. I unfortunately couldn't find any videos of Goulart Flutter. I tried, but so this is the best pictures I could have of the types of birds that might use this Goulart Flutter mechanism to basically offload heat. And then I wanted to talk about Gila woodpeckers and gilded flickers. We see these guys around a lot. I have some that live in my neighborhood and come to my hummingbird feeder. They live in saguaro cactuses. They basically drill a cavity into the saguaro cactus. Generally, they don't injure the saguaro cactus, so they know kind of where to drill it, and so they're not really affecting the saguaro cactus, but they're able to go into these cavities, and then it's cooler and wetter for them inside these cavities. So it allows them to be inside during the day and avoid the heat of the day. It moderates the temperature year-round, so in the wintertime it's cool, or it's warmer for them inside these cactus cavities as well. And then they also create a lot of environment for other bird species that are going to go in and use these cavities when, say, the woodpecker or the flicker is done using it. Other birds that aren't able to drill into the cactus themselves and create these cavities end up using these cavities when, say, the woodpecker or the flicker gives it up. So it actually is very helpful for other bird species around that aren't able to create their own cavities, that they're able to use abandoned cavities and still get this same heat benefit, either staying cooler in the summertime or warmer in the wintertime. That is it for mammals and birds of the desert. So thank you for sticking with me. I hope you enjoyed it. I enjoyed talking to you, and I hope you continue to enjoy our Adaptations to the Desert series.